Greetings from the bunker, my fellow Almontians, on this lovely St. Patrick's Day. Pardon me. I should be wearing my mask. I'd hate to give you guys a computer virus. I digress. Well, how you doing? Today is going to be a quick recap of Sedimentary Rocks, just to break you in real easy. Our do now is on the screen here. You got 5 to 8. That's in the new set of questions. So kindly hit pause and spend a few minutes on these, and when you come back, we'll go through those. See you in a minute. Okay, I trust everybody put some good hard effort into those questions. Let's roll through them here. Okay. Oh, let me get that screen up there. All right, so here's question 5, classic celestial sphere diagram. Anybody want to take this one? I cracked myself up. It's asking about which observation about the sun's apparent path at this location on June 21st is best supported by the diagram. Well, if you look at the options here, we'll do a process of elimination, probably the best way to go about here. The sun appears to move across the sky at a rate of 1 degree per hour. Well, this diagram, although that is a true statement, actually that is not a true statement, pardon me, it's 15 degrees per hour. The revolution is 1 degree per day. But this diagram doesn't really help you out with that one. So let's try the second one. Sunrise occurs north of east. Well, if you take a look, sunrise, here's June 21st. Here's north, here's east. So yeah, that's correct so far, right? North of east. So it looks like B is pretty good. C, sunset occurs south of west. Well, sunset south of west? Nope, not for June 21st, right? That's December 21st. Okay. And D there, the sun's total daytime path is shortest on this date. Well, we all know June 21st is the longest day of the year, so it wouldn't have a short path, it would have a long path. So, yep, we got to go with choice B, right? Sunrise occurring north of east and rising 15 degrees per hour. That would be noon, right? Solar noon. Coming down 1, 2, 3 p.m., 4, 5, 6, 7, 8. Right around 8:30 p.m. you get a sunset, and that's why the June 21st day, the summer solstice, is so long, because that path is so long. All right? All right, next one, we'll scroll down here. All right, this one is saying, at noon, on which date would the observer cast the longest shadow? Remember, the key to a long shadow is a low angle of sun. Okay? So you're asking yourself, well, which path has the lowest angle of sun? And I'm sure you realize that's December 21st, right? So lower sun means longer shadow. Which answer are we going with? December 21st, right? And AKA, that's your winter solstice. Do a little circling for you, yeah? All right, so we got December 21st on that one, and it was B on that one. Okay. Number 7 here. The length of time that daylight is received at a location during one day is called the location's, well, length of time, think of duration, Duracell, right? The batteries there, look at that prefix, Dura right there, right? That's duration, length of time. That's going to be talking about how long the day is. And remember, that's determined by the Earth's rotation, right? If the Earth sped up, our days would be, very good, shorter. And if the Earth slowed down its rotation, the days would be longer. All right. And the last one here, number 8. Based on observations made in the Northern Hemisphere, which statement is the best supporting evidence that the Earth rotates on its axis? Well, if you take a look at A, anything talking about seasons is not rotation. That's revolution. So that's out. Apparent solar diameter varying. That's got to do with the Earth's revolution again, right? The elliptical orbit. makes the sun appear bigger and smaller, right? If it was a perfect circle, the sun would appear the same size throughout the year. But again, that has nothing to do with rotation. That's revolution. The third one there, the stars appear to follow daily circular paths around Polaris. That's alluding to a rotation, right? Probably your best answer there. Or D, the length of daylight period varies throughout the year. Well, that's revolution again. The reason you get different length day and night throughout the year, that's because of the Earth's revolution on a tilted axis. Okay, so we're going to go with, which one did we say on that one? Choice C, right? And there it is. All right. So hopefully you put a little love into that. If you kindly meet me in the GC, it says sedimentary textures, I believe. All right, if you can't find it right away, obviously pause the video. So let me break this up here. Okay. How do we classify sedimentary rocks? Again, this is just going to be a quick recap to get you guys back on track. I'm sure everybody finished their bullets at this point. Yep, looking for 15 bullets, and yes, you can still submit your work even though you're not in class. Read it 125 to 130 if you have not. Looking for 15 interesting things, things that you found interesting during the reading. Okay? All right. So keys with sedimentary rocks, folks. The three key things, if a rock is sedimentary, you got to look at it closely. Does it have fossils? If the rock's got fossils, it's sedimentary. Okay? Second thing is, does the rock have fragments or clasts, right? Pieces of other rock cemented together. And if it does, it's sedimentary. And the third, does the rock have layers? Those are your big three clues to tell you it's sedimentary. And we're just going to talk about the textures here real quick. Okay, in group one, remember the other day you had a bunch of pictures on your desk, you had to organize what you thought would go together. Well, in group one, these all had one thing in common, and that's they had pieces of other rock cemented together, clasts. So they're clastic rocks, they're fragmental, and these would all be your land-derived rocks, and that would be on the top of your reference tables. And I'll flip back there real quick. Okay, the top of your reference table is right here, right? These are the land-derived sedimentary rocks, and they're clastic. They're pieces that are cemented together. There's the rock names. These are the size of the clasts that are cemented together, but that's what they all have in common, and that's what that first picture is showing you. Okay. The second one there, I'm sure it's jumping off the screen at you at this point. You can see what they all have in common. Anybody want to venture a guess? Very good. It's fossils. And fossils are found in sedimentary rocks because they form by gentle formation. Igneous rocks, right? The magma or lava would melt those fossils and they'd be destroyed. So sedimentary rocks are really neat. They're the soft rocks and they can preserve fossils. The last group is kind of strange because they are crystals forming, but they're not forming from magma or lava. They're forming from the evaporation of water. They call them precipitates. And when water evaporates, the minerals stay behind and they start to crystallize and they gently form crystalline sedimentary rock, not to be confused with crystalline igneous rock. Okay? One similarity, however, right, we talked about magma, the longer it takes to cool, the bigger the crystals get. Well, that's the same for sedimentary, right? The longer the evaporation process, the bigger the crystals get as well. Okay? And there's your groups, clastic, bioclastic, and crystalline. Then you got to here, and we ran through the chart, right? Clastic and non-clastic. I'll jump down to the bottom of the chart for the non-clastics right now. And here, right, and here you have on the bottom, you have your crystalline. These are marine-derived rocks, and what we talked about, the evaporation of water. rock salt. Obviously, when water evaporates and the halite precipitates, you're going to make rock salt. Rock gypsum, that's the rock that might save your life someday, right? If you ever, God forbid, you're in a fire. Gypsum is what they put in sheetrock, and that buys you some time. I think it's about 15 minutes or so that it's fire resistant. Dolostone, when dolomite precipitates out a solution, this will react to acids. You could do an acid test on it. It'll be a slower reaction than limestone. Limestone is made of calcite. Calcite reacts much quicker. So when you do your acid testing, if it bubbles like crazy, you've got limestone. And if it bubbles very, very, very slowly, you've got dolostone. Okay? On the bottom, we'll talk real quick. That's bituminous coal. That's the sedimentary coal, soft coal. This is not the coal they were shoveling in the locomotives. That would be metamorphic. We'll cover that in a couple days. But it's pretty wild because it comes from living things. It's organic. It's rich in carbon. And it is from the compaction of plants over millions of years. Okay. So back here, make sure you pencil in your notes, folks. Right, your clastic rocks separated by size, and the non-clastic rocks on the bottom of the chart. Okay. Out here is that gorgeous picture. Similar to like the Dead Sea or the Great Salt Lake, where all the salt just precipitates right on the shoreline. And I showed you guys a funny video in class of my son a long time ago, actually floating in the Great Salt Lake. It's very, very dense, and it makes you very buoyant. Okay? Okay, so just to go through the chart one more time, make sure you guys understand the different parts. Up top of the land-derived, they're separated by size of their sediment that's cemented together. That's conglomerate. The difference between conglomerate and breccia are the angular fragments, the rounded ones that were bounced around in a river for a long time and then cemented, whereas the jagged ones just broke off, fell in place, and were cemented pretty quickly. All right. As you go down the list, the sediments get smaller, like sandstone. In the lab the other day, you guys felt the sizes with your fingers, and you can feel it better than you could see it. And as you go down, they're getting smaller. Sandstone, that's a zoom in of sandstone. Siltstone coming up. You can't see the grains as easily anymore. And everybody's favorite clay made from shale, and you find a lot of neat fossils there. All right. On the bottom, the crystalline rocks from the evaporation of water. There's a classic rock salt. You could grind that up and put that on your chicken, but you'd probably have some dirt mixed in. It is not pure halite. If it were, it would be considered a mineral. This has impurities, which makes it a rock. There's your rock gypsum, dolomite, and just different samples as you go down the chart. The odd man out is the bioclastic, right? The coal. This is not formed from the evaporation of water. It's from the compaction of plant remains. But it too is still a sedimentary rock. They call it bioclastic. Okay, little progression through coal. You have this in front of you in the GC. Plants living a happy life. Plants dying, getting buried, they get compacted, and ultimately turning into coal. Okay? On your chart, just to fill in the rest of your notes there, kind of organizes what we went through. Okay, give you a second to look that over. If you got to pause, please pause it and continue on. All right. And for the summary questions, real quick, if you take a look, you can clearly see fragments here, right? So if you're seeing fragments, it's definitely sedimentary. What observation about the rock best supports this classification being sedimentary? Well, it's got pieces of other rocks cemented together. Okay. This one here, get an answer before you see me do it, please. Most rocks that form from fragmental rock particles are classified as, well, there's that key word right there again, right? Fragmental. You're talking classic sedimentary rocks. Okay. Which material is made mostly of the mineral quartz? If you remember from the mineral lab, quartz is the main ingredient in glass, right? It has a hardness of 7. So clearly you'd have to go with window glass on that one. Okay. Well, there it is. I hope you followed along. If you got to watch it again, feel free. Please make sure you put some effort in, folks, while you're at home staying safe. And report back as soon as you can for our follow-up lesson. All right. Take care.